play, yes. So talking about how a slot machine works. So when you're designing an interactive installation, or you're designing something in Touch Designer, somebody let maybe Scott in. Oh no, it's not. It's sometimes really helpful to think about it as a mechanical device, or at least a mechanical process. I mean, in this example, we're actually emulating a mechanical device. So we can think about or do research about how the mechanical device works in order to give us ideas about how to program this. Or you can just kind of examine it in your head. And if you can get a good enough description of how you think it works, you can probably reproduce that in code to make it work. So let's talk about how a slot machine works. So I could go into detail research, and I've done this in the past, showing like all the different components of the interior of a mechanical slot machine. Nowadays, slot machines, even ones that have mechanical wheels, are actually just a computer program, and the computer program is picking a random sequence, and that it's not truly random because they actually pay out based on a payment scale, and the amount they pay out is based on other times that they've paid out, so that they only are ever paying out this percentage that they've agreed with the Gaming Commission is legal to pay out, and they're not going to pay out more than that percentage because that's how the casinos make their money. So, and then once that sequence is established, then the computer tells the wheels to spin on their motors and stops them where it wants them to stop. So it looks like it's a mechanical device, but it's not. Previous to that, though, it was a mechanical device. If you're talking about slot machines from, I don't know, the 70s, 60s, 50s, and earlier, 1800s slot machines, those are all mechanical devices. And, well, I guess before I describe how they work, I want to get your guys' ideas about how you think a mechanical slot machine would work. So I think one of the first things we should establish is, what is the gameplay when you walk up to a slot machine? What do you have to do before you can play it? What happens when you play it? And what happens when the game is over? Anybody want to dive in? So what happens before you can play a slot machine, what happens?
Yeah. Drop a coin.
You have to put money in. Then what happens? Then what else do you have to do?
Select your bet.
You select a bet, and then what else?
Then pull the lever.
Pull a lever, right? So you put in money, you select your betting lines, because most of them are on multiple lines. We're not going to build a slot machine that complicated. We're going to do a single line slot machine, kind of like an old one-armed bandit. So that part of it wouldn't be necessary, because we're only going to bet the single line across. And then, of course, pull the lever. So put money in and pull the lever, or push a button, or have a fake lever that you're engaging with, and it's really pushing a button, right? Which is what we're going to do right now. Okay, so then what happens? Wheels spin. And all three of them spin, right? And then what happens?
They stop one at a time.
They stop one at a time. Which one usually stops first?
Far left.
Yeah, usually the far left, then the middle wheel, and then the final wheel. And the reason why they do that is because they're trying to build up anticipation in you. If they just had them all stop with their random numbers, that would not get you, it wouldn't provide a hook to the psychological part of your brain that thinks you're going to win, right? If it's completely random and it's completely cold, a cold process where they're just giving you 3 random results, then when you don't win 10 times in a row, you'll probably quit playing the game. Whereas if they build up this anticipation that you might win, you'll play more than 10 times, still losing every single time, right? So that's why they make them stop in order. And they also, what else? When they stop, so are they just going at full speed and then clamp stop? Stop instantaneously on one number?
Some of the newer digital machines do that, and it's weird.
Yeah.
I guess they're supposed to slow down.
Yeah, usually they slow, the wheels slow down to some slower speed and then stop, right? And then what happens?
And you read them, and usually it's too complicated to understand what's going on. The machine just tells you whether or not you get money.
That's true, and that's and modern slot machines, they certainly, it's kind of like roulette in that there's a million different ways to bet, and also what craps. There's just like so many different ways to bet that you don't even really know what you're doing half the time. And so that way when you lose, you're like, oh, I guess I just didn't understand it very well, instead of this game is just cheating me.
Or you get 3 different pictures and you get some, it spits out a couple coins.
Right. So, anyways, the game, after the last wheel stops, the game is analyzed to see whether you win, whether you met win conditions. And I don't think we won't get to the win conditions or the logic to do that today, but essentially we'll have a couple win conditions. 1, are all 3 of the things the same? 2, are all 3 of them lucky 7s, giving you like a jackpot, right? 3, we could do, I've done in the past like an ascending order, like 1, 2, 3, and descending order 3, 2, 1 as a win. That's a possibility. And then 4, how much is each one of these conditions worth? And then add that to your point or money total if you won. If you didn't win, then just subtract the dollar or whatever it costs to play, right? And then what else? Then what? Then there's a payout, right? Then it spits out money. And we're not going to be able to have anything spit out money, obviously, but we can have it. What?
That's the joy. What's gonna motivate you to play?
Well, just that. Well, we're going to keep track of how much virtual money you've made or lost.
So it's like Bitcoin.
I suppose. Probably has about as much value as Bitcoin right now. And then I'd say for our payout, we could trigger sound effects, we could trigger videos, we could trigger like a fireworks sequence. The classic like payout that I can think of in a visual sense was like remember the old solitaire program that when you got all the solitaire cards, they would start bouncing across the screen? I loved that so much. It was like from Windows 95. Are you guys old enough to remember that at all?
Yes.
Yeah. The bouncing cards. That's basically it was made the entire game worth it just to see if you could get those bouncing cards. So we might do something like that on the payout. But let's see, where were we? So yeah, that's kind of the sequence of how it works. And so how a real mechanical slot machine works is when you pull the lever, inside there is a thing called a kicker that kicks the wheels based on a spring, and it engages with these wheels, I believe, on a clutch mechanism, where the clutch mechanism is changing the amount of torque slightly each time it's engaged. So the next time that the kicker hits it, it'll either impart more torque or less torque than the previous time that it hit it. And then there's also a fan blade in there that spins around, and the air pressure causes that the slowing down of the wheel to be unpredictable. So they've added these mechanical randomness to it to get you so that you can't predict. Otherwise, if it always slowed down the same way and it always imported the same amount of force to the wheels, then you would probably be able to figure out like a pattern, like, oh, there's an 80% chance it's going to pay out the next time I do it. And they don't want you to be able to figure out a pattern at the casino, right? So what we need to do is first create these wheels. We're going to start by putting numbers on them because that'll be easier for us to track for math-wise and to track that when the thing says it should be 1, that the 1 character is in the middle of the wheel, that kind of thing. And then we need to make those wheels spin. Then we need to impart randomized speed to the wheels. And then we need to impart a randomized timer that makes the wheels stop. So let's get into it. Let's make a new, we're going to start from scratch. Go ahead and go to the website and download the content on week 5. Wait, what am I doing? Cancel. I always say new project when I mean new file. New. All right, so as soon as you got it, drag the slot machine.obj into your touch designer, and you should see the slot machine model. I've taken this model, I believe I got it from 3D Warehouse, from SketchUp, and I edited it to remove some pieces so that we can actually stick wheels inside it and see the wheels spin. Okay, so all right, we got our slot machine. That's cool. You guys all with me? All right, I'll give you a minute to get everything downloaded. All right. Once you get your slot machine in there, then we're going to create the wheels, and we're going to use more 3D objects, which are, of course, our surface operators, or SOPs. And we need a cylinder, basically. But they don't call it cylinder in here, because they got to be different. They call it tube. So it creates a tube. So put a tube in here. What? I guess you can set the go ahead and turn on, make your viewer active and rotate the tube. By default, it's an open cylinder, which is kind of like a tube, I guess. But you can over here in there is a mode in here to make it have an end cap. End caps here on detail. If you turn that on, then it has solid sides. Doesn't really matter for our purposes. I don't think we'll see the sides, but I had them turned on in my example. Okay, so the next thing, this cylinder, or tube, this tube I should say, is oriented like this by default. And we actually want it the other way, right? We don't want sideways spinning dials, we want vertically spinning dials. So the easiest way to deal with that is in the parameters for tube, there's an orientation parameter, and change that from y-axis to x-axis. And then it turns it 90 degrees for us. Okay, now we need to put numbers on this tube. All right, so we're going to use text at first. We're going to use a text top. So create a text top. Okay. We need this text top to have a highly vertical linear aspect ratio. So let's change the resolution of this, and I tried out a bunch of different resolutions, and I found the best one was somewhere about 75 pixels wide by 380 pixels tall. Okay. We are going to throw out this derivative text. We don't need that. We almost never need that. And we want this to be numbers going vertically from top to bottom, I believe. Yeah. And that's a little bit challenging to do by putting things in the text field, because if I start typing here, it wants to put things horizontally. And you can rotate it, but then its orientation is sideways, and we want each number's orientation to be normal, but we want the next number to be underneath it. Like, like that. So we need them to be on different lines. And this text, I think it's possible to insert text with line fields here, but it's way easier to just do that with a text editor, or at least a text dat. So let's do that. Add a text dat text. Okay, and then go ahead and open the text editor by hitting the edit button on the parameters for the text dat, and that'll open up whatever your default Python editor is. So if you have Xcode, as your default Python editor, it'll open up Xcode. Xcode takes an extra couple seconds to load, which is why I switched it to Text Wrangler. All right, so now we just want a new number on each line of this. So I'm going to start with 0. I'm going to make 10 numbers starting from 0 and going to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
If we don't have a default text editor, is there a way to set that in preferences?
Yeah, so it's whatever. If you open a .py file, it's whatever your computer opens that with. What happens? You're on Windows. What happens when you go hit the edit button? Oh, nothing, huh? Okay. Well, you would have to, in your Windows, find something named .py, and then change what the default editor. I think, especially with something this simple, we could actually do it inside the object. So here, and let's just go ahead and do that. Whoops. So I'm going to go ahead and save this and close it. And I have it here in my field. You guys don't. But you can click on Viewer Active on this and just put in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that works too. In fact, that was so easy, it's probably what I should have done in the first place. All right. Okay, so now we want to, on our text top here, we need to specify this text 2 as the dat that we will be using to generate the text. And that's right here under dat. I say text 2. And there we go. We got numbers. Yours doesn't work. What happened? Okay, so we need these to fit on the screen, and so be a little bit smaller than they are. They need to fit inside of this text 1, so go back to font size and bring that down. And you want it to be kind of equally spaced. I think that's about right. 22.5 is the font size I believe that I have for that. If I went like this, if I had it too small, then there would be gaps between 0 and 9 on the cylinder, and we don't want that. So I believe it's 22.5. Did I write it down? No, I didn't. I'm pretty sure it's 22.5, but we'll find out soon enough. All right, so now, right now we are generating white text, and our cylinder is going to be white, so that's not going to work. So over here on color, we want to change the font color to black. we want the background color to be white, and we want to turn up the alpha for the background color, because by default it's down. So if we turn that up, then we get white text or black text on a white background. Okay? And so now, how do we get this texture operator, texture operator top, how do we get that onto our tube SOP? A Phong. A Phong, which is what? What is a Phong? It's a material. So we first need to create a material, and then we need to apply the material to the SOP. How do you apply a material to a SOP? There's one other object you need. So you do need the Phong to create the material. And then you need a material SOP to apply the material. So coming out of the SOP for the tube SOP, get a material SOP. Material there. Whoops, not magnet. Darn it. Come on. Come on. I'm clicking the wrong place. There we go. I should be using my mouse, then I wouldn't have so much problems. Okay, material SOP. And I need to set Phong 1 as the material. Like that. And currently that doesn't do anything because we haven't applied anything to. How do I get this onto the Phong? Drag and drop. Let's just try it. And then you choose either color map usually or diffuse map. We want color map. And we're close, but that doesn't look right. All right, so we actually want the texture to be rotated by 90 degrees. We needed the numbers to be in this orientation, but then we need it to be rotated on its side. So the easiest way to do that is, because you can't really, here on this text top, you'd think that there's a text top that there'd be some way of rotating this, and there isn't. Right? There's no way to just say rotate this by 45 degrees or rotate this by 90. You could with a transform, but we actually want to use a different one called flip. Flip. And flip allows you to flip the x-axis, which would make it reversed mirror image. You can flip the y-axis, which makes it upside down. You can flip both. In our case, we want to go here under the flop. So under the flop drop-down menu, you want to choose, I believe, bottom left. And now it turns it on its side, but it's flipped on the x-axis. So that's why it's like mirror image. So flip the x-axis like that. Okay, now go ahead and do I apply that, or did I go? Yeah. And now go ahead and apply this to the Phong instead as the color map. Now you get a orientation on this donut, kind of like a clock rotating around. And even better, look at the tube. We have a beautiful two wheel. I think that's right.
And the Phong just drags onto the material to route it to the tube.
You can drag it onto, I believe you could drag it onto the material like that. Yeah, you can drag it onto the material, or you can type in its name here under material. Yeah. All right, so now we got a tube. I mean, we got a number wheel, I mean. So let's try spinning this number wheel. Before we can do that, though, it's going to be best to put it inside of a geometry container. Yeah, we want to put it inside a geometry container so that we can spin the entire container. Right? Because you can see that even this, there's no rotate command, I'd have to use like a transform top or something like that. And it's a lot better to just stick everything that you want to rotate together as a group inside of a container. So let's create a container, comp, not a container, sorry, a geometry comp. Right? So anything, every 3D object that has geometry that you want to rotate together, you'll put in a common geometry container. All right, and let's go ahead and name this wheel 1. Okay? Okay, go inside your geometry container, get rid of the torus. And in the past, we've sometimes done select tops to not have our stuff inside the geometry container. In this case, we just want to put it in there because we don't want our main patch to get too messy with too many objects. So you can leave the slot machine object out, but everything else, this text and the tube and all that and the Phong, we want to cut all of that from here. And then go inside of our wheel 1 geometry container and paste it. Okay. Yeah, and now, let's see. Let's go ahead and add a null here at the end, coming out of the material, and make that render active and display active, or set the render and display flags on that. And now when you hop out of your geometry container, you should see the wheel there. And if we grab the, let's see, here on rotate, if I want it to spin toward me, or spin like this, what axis do I want to apply the rotation to? Well, all you have to do is think about the axis as the place where the bearing would be, right? In something, or spoke, or axle, where the axle of the thing would be. So if it's spinning around the z-axis is pointing at you, and then it spins like a pinwheel, like this, right? Around that axis. If you spin it around the y-axis, it's like this. It's like rotating in a chair around the y-axis. We want it to spin this way, which is around the x-axis, right? So go ahead and just make a rotation of 45 degrees in the x-axis, and you can see it's moved the wheel slightly, right? Let's create a way of, go ahead and set that back to 0. Let's use a slider to test this out. Create a slider comp. So this slider goes from 0 to 1, I believe. Go ahead and attach a null chop to this output of the slider. Okay, so you can see if I make the viewer active on the slider, it goes from 0 and it goes up to 1. If I sent that to if I mapped that to the rotation of this cylinder, how far would it move? It'd go between 0 and 1 degree. So not very far, right? So I could multiply this by 360, but think about our number wheel. We have 10 numbers, right? And we want to actually analyze those as numbers to be able to do math, to be able to decide whether things are the same or not, because there's no like logic operation that says a strawberry is the same as a strawberry, right? But there is one that says 1 is equal to 1, right? So we want it to have 10 positions, and those 10 positions cycling through all 10 numbers will cycle through 360 degrees. Okay? So we can do that, of course, with a math object to do ranging. So the first thing we want to do is take our 0 to 1 and range that between, we could go 0 and 360, but we want to establish these 10 positions first. So we can take the 0 to 1 and have that go between 0 and 10. All right, so now when I slide the slider, I still have, values in between 1 and 2, in between 2 and 3, but it goes all the way up to 10 and all the way back down to 0, right? So we have 10 values there. Now I can map this to the rotation, but what would I want to do if I wanted a number that goes between 0 and 10, to create a rotation that goes between 0 and 360? You could do another math thing, but we're going to be associating these with Python code. So we could just put that. It's a pretty simple expression, and we can just add that to the expression. If you went from 0 to 1 on your number wheel, how many degrees did you rotate? 36. He's got it. He's got a TD's mind. So 36, right? Because 10 times 36 is 360, right? So all we have to do is say, coming out of math 1 here, right? I had it going to a null first. Let's have it go to a null, just because it's better to export from a null. And here back on the wheel, I want to, on this rotate, go ahead and expand that. And on rotate X, I can switch over to expression mode. And I can actually go ahead and make your null 1 or null 2 here. Make that active and drag that over to Rx, and then it says, and create a relative chop reference, right? So it has referencing, and look and notice the way that it's referencing the value, because when you're referencing chop values, there's a couple different ways you'll reference values. You're either going to be referencing a parameter value, or if you're referencing a chop, you're referencing a channel. You might still be referencing a parameter value if you're interested in the chop's parameters, but you usually are interested in the chop's channel data, right? Because it's a channel operator. That's what makes it a chop. And so this is saying, hey, look at null 2, and then look at the channel called V1. And so you'll either see something like op null 2 dot par dot whatever the parameter is called, and then the value, or if it's a channel like this, you'll see null 2 and then an open bracket and a value that corresponds to the channel's name, right? You can either specify this thing by name. In this case, they did it as V1. We can also specify it by index number if we don't happen to know or we don't care about what its name is. And that would be channel 0, because it's the first one, and there's only one here. So this would be the same thing as saying V1. And I'm going to use this bracket 0 a lot today, because it's just easier than trying to keep track of what the channel is called, especially when you're dealing with one channel operators.
Because there's only one channel in the null.
Yeah. But if there were 2 and I wanted the second one, I could say, instead of 0 here, I could say 1. And then it would be, starting from 0, it's the second one. All right? Okay, so we need that. And then times how many degrees? 36. So now, if I rotate this, it goes from 2 at 0 and should end up at 2 again at 10. So it's rotating correctly, but wouldn't it be great if the number coming out of this here on the math 1 or the null 2, this number correspond to the same number. So like if I have this on 1, that this is a, wait, it is the same number. Is it? No, it's not. No, it's at 2. Okay, yeah, that's what's going on. First of all, it's rotating the wrong direction. So when I go forward, the 2 is counting down. And so we actually needed to rotate the opposite direction. And if you look at slot machines in action, they actually rotate this way. Not the other way. So all we have to, what would I do to change the rotation to the opposite way?
Negative 36.
Yeah, you could times it by negative 36. And now, okay, so now it still goes from 2 and to 2, but now at least when I'm going forward, it's also making that number increment, even though it doesn't line up perfectly yet, right? So at 1, I'm on 3. At 2, I'm at 4. At 3, I'm at 5. So how do I fix that? Basically I need to create an offset rotation, right? So you just have to figure out what to put after this times negative 36 plus some offset rotation, right? Plus, I don't know, let's try, what is it? I know what it is, but let's just try something random, 50. So if I offset 50 degrees, I want this to be at 0. I'm close. So go ahead and move your slider all the way to 0. And then here on the plus, let's just try some different values until we get that to be centered right at 0. 55. No. 60. We're getting closer. 70. Well, that's pretty close. That's really close. I had 72 in my notes. 72. I felt like that was the closest. And so now once I have that set up, when I rotate this thing, and now you can see that the value coming out of this is 3.03, and it's centered right on the middle of the 3 here. Okay? Is that working for everybody?
I'm kind of getting my material in the fall.
Let's go ahead and save your project right now, because I did have a crash issue when I was building this. Slot machine. I'm putting class on mine because I have my prep already. What's your issue?
The phone won't go to the material. It's telling me not enough sources verified. Specified. So that's what it is.
Yeah,
It says phone.
that's a weird one.
It was giving me that, and I had to rearrange that over.
Should have, so the tube should go into the material, go into the null.
Tube goes into the material. Like
Yeah,
backwards.
I know, it's
That's what happened.
Thank you.
it like,
Is anybody else having any issues?
My 0 is like.
Okay. What did you specify for the resolution of your top?
Whatever you said.
And what did you specify for the Yeah. So, okay, your issue probably is on your font size.
22.5.
I do have 22.5. Okay, and then your the text.
75 by 380.
That's right. All right. Let me see what yours looks like. Go inside. Oh, zoom in. I can't see it. No, don't do that. Zoom in. So, no, yeah. You just scroll up with your okay, so that doesn't look very centered to me. That 9 looks a lot higher than my 9. So let's see why. So on your text, font size, text, color. Do you have an extra space in your DAT or something? take a look at, let's look at your DAT. That looks right.
Yeah,
Oh,
because see
because of the 11?
Yeah, you have an extra space? Yes.
Oh, yeah.
So make sure you don't have any extra spaces in your DAT. There we go.
Great, thank you.
So Kathleen just had an issue where her numbers weren't lining up right, and the only reason why was here she had an extra space after 9, and that messed everything up. So we don't want a blank space after that, so that's why.
Cool, thank you.
Cool. Does anybody else having any issues?
Two times showing up as a
Oh, then you need to make sure that the last thing, your null, has your display and render flags set. Okay? So we got that, and we got it spinning, and we got the number here to line up with what the number is displayed on our wheel, right? So that's all hunky-dory. Now the next thing would be to, we can create more than one wheel and put them inside our slot machine. So the great thing about the fact that we put it in a inside of a geometry container, not only can we rotate the entire thing or any objects that are in there as a system, we've just contained all of that code, and we can now easily copy and paste it and duplicate it. So now we have 2 wheels. They're going to be sitting on top of each other right now. And then now we have 3 wheels, and we just need to set our offsets to get them to be in the right place. But before we can tell that, we need to set up the slot machine to be rendered as well, and set up everything to be rendered, because right now we're not rendering anything. So let's render the slot machine. So what do we have to do to render the slot machine? We have to put it inside of a geometry comp. Geometry. And let's just go ahead and stick it inside. So get rid of that, grab this, copy, paste, and turn on, actually, yeah, we could just, all right, for now, let's just turn on the display and render flags for this. Okay, so now we have that, and now what do we need to be able to render this stuff? Camera, light, and a render top. We have, and geometry component, which we already have 4 of them now. So, okay, so a light. We're gonna need a camera. And then we'll need a render top. And there we go. Now we got 3 wheels. They're way too big, and they're sitting all sitting on top of each other. And actually, it's probably the easiest. We've already duplicated this, but we should probably just delete these and set the first one to the right size and position, and then copy and paste them, because then we won't have to do it over and over and over again. So just have the 1 wheel for now. Okay, so we need to scale and translate this wheel. So we can scale it in the same place that we were rotating it, here under translate and scale, but we're going to scale all 3 X, Y, and Z uniformly, so we can use the uniform scale instead of having to set 3 different values. So scale this down something, I don't know, something around something less than 0.2 for now. 0.17 is what I have right now. And now we want to adjust the placement of this stuff. We're going to need to move this up, but really look at our render, like everything is up too high. So we, let's see here. The slot machine's up too high. Let's just move that down first of all. Grab the slot machine's geometry. Mine's called Geo1 right now. I'm just going to rename that slot machine. And I want to move this down 1. So on the translate, -1 on the y-axis. And see how it puts there's like crosshairs. There's a little bit of a weird offset on this that actually doesn't apply to its positioning on the render, but it does on the geometry component. Everything's always over to the side. I'm not sure why. I think it has to do with the model itself. But you can see, from what you can see that this is there's a kind of a crosshairs here of the x and y axis, and I figured out to get it to -1 by trying to get those wheels kind of in the center of that crosshair, because we want ultimately we want the camera to be centered on the wheels, right? So it's actually like -1.02 or something. Doesn't really matter. -1 is close enough. All right. And so then that's looking a little better, and actually the wheels are more centered now. They're still okay. So now it's apparent that the wheel is still too big. So let's scroll down the wheel size until it makes a little more sense here on uniform scale. Something about, what am I at? Oh, I'm at less than 1. I think I had it before. Mine's looked about the best at like 0.104. And then the other thing that's up with this is that it needs to be pushed back into the slot machine. So let's go ahead and adjust this Z translate on wheel 1. And yeah, go ahead and let's use the value ladder, and you can click and hold and then scroll to the side. Oh, you know what actually works the best is highlight your render and then hit this square up here to open the viewer, which, oh, that doesn't work yet because we have to have an out. Make an out for your render. Coming out of the render, add an out. Remember, you need one of those to be able to visualize this in perform mode or whatever. Go back to your render and open a viewer for it. And now, now highlight the wheel. You can resize this window. You can make it whatever size you want. Go back to your wheel and start pushing it backwards until it disappears inside the machine. You can see kind of when it's in front. Look at the gray border above it, the darker gray border. I want it to just barely clip that dark gray border, the darker gray border. So I have mine at about -2.5 or -2.2. That's what I had in my notes. Okay, so now that's about in the right place on the Z scale. It's a little bit pushed to the right, so we need to translate it to the left a little bit. So I'm grabbing onto my value ladder, and I'm going to scroll this thing over until I feel like it's more centered. That looks good to me, -0.03. Okay. And let's push our camera in so that we can get a better view of this to kind of finalize these. So your camera right now, if you click on the camera and look at the parameters, it's at -5 by default. Not negative, it's at +5 in the Z scale. We want to get closer, so let's make that like 2. And then let's make that like 1.5. Let's just go straight for 1. There we go. That's looking pretty good. We're gonna want to be able to kind of rotate the camera to look at it at an angle, but we still want it to be facing. We want to set a look at point, right? You guys remember last week how you can create a target to look at and have that target be different than any specific object that you have located in the scene? No? No one? A null what?
Geometry?
Comp. A null comp. It just creates a reference to a point in geometrical space. So let's call this null comp. Call it camera target or cam target. All right, and now here on camera, you set the look at as cam target. Okay, now if I push this target around, well, this target currently is sitting at the origin 0, 0, 0, and I can push my camera around and I'll always be looking at that target. So let's go ahead and push the camera over to the right a little bit. So on the translate, I'm just going to grab the value ladder and point 1, and I'm going to move it over a little bit, and I want to move it forward again. So moving it forward is going closer to 0. Yeah, that looks about right. Where I have the wheel set back inside of the model like that, but not in front of it. There were glass panes in front of this that I just deleted from the object. We might put those back in a later version of this when I figure out how to make things clear. All right, so does your guys look like this? Does anybody have an issue? Great. All right, so now, yes, you do. What's up? You can't see your wheel at all. Okay, so that's probably just that you have to have the render flag set on your geometry. So what's the last thing with this? Go inside of the wheel, and you don't have the render flag set there. The purple one. Got it, great. Yeah. Okay, so now let's make the other two. Go ahead and put your camera back to where it was, basically. Which I believe is like, well, let's just put it at 0 on the X. And point, or what was it? We just need to move it back a little bit. So like 2 on the Z. Yeah, that looks about right. Okay, great. So now we got our one wheel and it's in good place. And so now we can copy it and make other wheels. So grab your wheel 1, copy and paste it. It's sitting on top of the other one, copy and paste it. They're all 3 now sitting on top of each other. But all we have to do is grab the X values and slide them over. And this is actually, the wheel 1 is in the middle right now. So let's slide it over all the way to the right, to the left rather. So I'm using my value ladder. And I had it up too high. Whoops, way too high. Sorry, 0.1. Oh, negative 0.1. All right, so if I drag the value ladder, make sure I'm on 0, 1, so I don't go flying across the screen. That looks pretty good. Negative 0.14. And then wheel 2 is still in the center. And then wheel 3, try grabbing this and drag it the other way until that looks centered. That looks good to me. And so now I have 3 wheels. And currently these 3 wheels are all driven by the same slider, but I can drag this slider and you can see all 3 wheels moving. Okay? I think we'll have to, at some point, we're going to have to offset this rotation a little bit more because the wheel is notating 0, but it doesn't look like it's in the middle of that of the display because the display is slightly rotated or is slightly slanted backwards. So all we have to do is just kind of offset this rotation so that the 0, set your slider all the way to 0 and then start offsetting the rotations on these. Right here, remember we have op null 2, channel 0 times 36 degrees plus 72. I'm going to adjust this plus 72 until I feel like the 0 is in the middle of the window. So plus 60 maybe, 55. That looks a little better. 54, 50. Let's see if 50 is too much. I feel like 50s is too much. 50, 52, 52 look good to me. Okay, so I offsetted that to 52. I can do the same thing over here. Change all these 72s to 52. So that way the 0 is in the right place when it's facing this way to match the rotation of the slant of the face plate of the slot machine. Okay, it's 2 o'clock. Doing good. All right, so now we got a slider that controls this. We don't want that to be our end state. In fact, we want this thing to move by itself. So we are going to do that with a timer. So we're going to create, well, first, actually, before we can have a timer, we need an automatic process to make these things move. Does anybody know what chop creates like an oscillating or a signal that changes over time? We've used it before. What? Noise would work, but I think we don't want the wheel to be like randomly jumping all over the place. We need it to be spinning, right? What?
LFO.
Got it. LFO. An LFO chop. So an LFO chop, by default, it creates a value that goes between -1 and +1 back and forth. That would make our wheels seesaw. So that wouldn't be exactly what we want. But we can change the pattern here from sine to ramp. And then it will go between 0 and 1 and then go back to 0. And if we tied that to replace our slider into this null with this, then all of a sudden our wheels start spinning. We can get rid of this slider now. We don't need it anymore. Whoa! Get rid of the slider. We don't need it anymore. Okay. So now we just need a timer that turns off this wheel. It turns off the wheels as they on a random basis, right? So let's see. First of all, well, okay, that's fine. Just right now, this is all tied to all 3 of the wheels, and we can just keep programming it this way, and then create separation pretty easily with a few lines of code after we get it working. All right, so we're going to add a timer chop. Timer. Let's look at how timer works. So timer, you create a length over here with the slider, and by default it's at 10 seconds. You can set that to something smaller, like 5 or 4. And then you send it a start command, and it starts counting down. And it shows you the fraction of that time as it advances. And then when it's done, this channel that's called done flips from 0 to 1. Let's go ahead and initialize that again. So I'm clicking the start button, and you can see the done goes to 0. And then when it's done, the done goes to 1. So we could use that done channel to make our LFO go or stop. Anybody have an idea how you could do that? Using Python, maybe? All right. Well, the first thing is let's isolate out the channel that we want so that we aren't dealing with an operator that has multiple channels that we don't need. Right? So you can, to do that, you use a select chop. We've used select tops and we've used select SOPs before. This is a select chop, which allows you to either take an input and select a particular channel, or it also allows you to like send and receive in different places of your patch without having wires going between them. That's kind of the way we've used selects in other senses. In this sense, we're going to use it to actually specify a particular channel that we're interested in. So here under channel names, the easiest way to interface with this is to click on this arrow on the right-hand side, and it will bring up a menu of the different channel names of whatever you have attached to the select. In this case, we want the done channel. And so now we have just the done channel coming out of this select. And looking at the LFO, what makes this LFO go and what makes it stop? And what controls its speed? Play around with the sliders until you figure out what makes it go and what makes it stop. What? What'd you say?
Frequency?
Frequency, yeah. So if we made this have a frequency of 0, it stops. If we make it have a frequency of 1, it goes really fast, or it goes its full speed. If we make it have a frequency of 2, it goes twice its full speed. So we have over here, we have this done that when we engage the timer, the done turns to 0, and when it ends, the done turns to 1. How could we use that 0 and 1 to make the LFO go full speed when done is 0 and stop when done is 1? It's basically the same thing as setting that frequency as 0 and 1, but it's the opposite, right? Because when we want it to turn, the done will be 0. When we want it to stop, the done will be 1, right? So how can I flip that over? This is a really common thing that you'll do in logic operations all the time, where you have the opposite event coming in that you want to flip over. And the easy way to do it is simply, especially when it's 1 or 0, what is 1 minus 0? What is 1 minus 1? So there you go, you flipped it over. So it's 1 minus the value. So here under your LFO's frequency, if I go into, grab your select, put your select in viewer active, highlight your LFO chop, drag the channel over to the frequency, make a relative chop reference, or you can type this in. You can type in 0 or op select 1 and either the done channel, or you can put in just channel 0, which is the same thing. And then on this, say 1 minus that value. And so now it's stopped. And if I go back to my timer here and I start it, I say start. Then it starts counting down for 4.7 seconds. And after 4.7 seconds, it stops. So that's cool. That should work. Yeah. So here I'm just triggering this manually right now. We're going to trigger it with a button here in a second. But so here on LFO, make sure that you have on the frequency that you have 1 minus channel 0 of this op select 1, right? So that way, and then you go back to this timer and you hit start, and it will start counting down, and you can see that this select 1 turns to 0. That's why we said 1 minus, so that way it's 1 and it starts turning. And then when it switches to 1, it stops the wheel in its tracks, dead. We're actually going to create a method of making it ease out in a minute. and then further expand on that to make it go at a slow rate until it gets to a full number and then completely stop, so that you don't stop halfway between 6 and 7 and not know which one it is, right? But before we do that, we have to add randomness to this whole thing, right? So is that working for everybody? Is anybody having any issue with this so far? Let's add a button to this. So right now we've just been triggering it by hitting the start button in our parameters menu. That's not going to work very well as an interface. But we want to add, we can just trigger it with a button. Just add a button and attach a null chop to the output of this button, so we can see the value. Go ahead and make your button viewer active. Click on your button and you can see by default it's a toggle. It turns its output to 1 when I hit it and back to 0 when I release it. We actually want this to be a momentary button that we don't have to hit twice to get it. We just want it to go to 1 and then back to 0 when we let go. And that's just a mode of this button. If I go over here and button type, toggle down, I change that to momentary. Now when I make this, it just goes 0, 1, 0, 0, 1, 0, 0, 1, 0. Right? I can patch that into here where it says the second inlet on this thing. What's the first light? Oh, that's initialized. We don't need to initialize it. But this input 1 start trigger, if I attach that, then when I hit the button, it'll start the countdown clock. Yeah, so let's look at what that looks like on our slot. Oh, there it is in the corner. Yeah, so now they're all rotating together. They spin for a set number of times and then a set number of seconds, and then it stops. So we need to add randomness to this. Oh, look at that, lucky 7th. That's pretty easy when all 3 of your wheels are locked together. All right, so we're going to add randomness. How would we do that? Well, so far when we've done random numbers, what have we used? Anybody? We've used noise. We've used noise chops. We've used noise tops. We're going to use Python this time. So I'm showing you guys more and more different Python stuff. And next week, I believe, we'll start actually doing a lot of Python. All right. So we're going to use some Python functions here. And there's a couple ways you can execute Python commands. You can do it with Python parameters. Python code in the parameter window, where you're creating some sort of relative reference between 2 objects, and it can, using the Python script, as one object's value changes, it's changing the other object's parameter, and maybe you've added some math to that, like timesing it by 36 degrees and adding 72 to it, like we've done, right? That's one way. Another, but if you want it to, like, on a condition, run a Python script, then there's a couple different objects that you'll want to use. The most common one is what's called a chop execute, which sounds like it would be a chop, but it's actually a dat. All right, so in dat, make a chop execute. What this does is it takes a chop as its input, and you specify that chop here, or you can drag a chop onto it to specify that. And then it has different conditions. It'll either run code on any value change, it'll run code on an off to on, a while on, a on to off, and a while off. So those are your different options. By default, it's running it on value change, which I think it should be off to on or on to off as its default, because that's what I use it for 90% of the time. So actually, let's change it to it's running on off to on. And the one thing about this object, if you don't have, you can put code in the particular place, that you want it to, that you need it to go, but it won't do anything unless you've turned it on here in the parameter menu. So you got to make sure that if you're putting code in this under here where it's like defining on to off, that you turn on that function over here if you want it to actually run. So you turn on the function, the condition that you want to run, then you can go in here and edit your code. And you want to put your code in the definition that corresponds to the function over here that you've specified. So if I am wanting code to operate when it goes from off to on, then I would put it here before this return on the def off on to off. Def means define. It's defining this function, right? The thing about Python is that it is what's called, I believe, white space dependent. So it looks at your white spaces to figure out things. And if you put extra white spaces in, what do I mean by white space? I mean spacebar, I mean tab especially. If you put in extra tabs where they don't go, it gets confused. And if you don't put in tabs where it expects you to put in tabs, it gets confused. So, and when you're defining things, you start with this definition full to the left side of the screen, and then you indent with a tab 1. And everything that's indented with a tab is part of that definition. Anything that's not indented will either not be considered as part of the definition or will cause an error and make you sad. So just make sure that you tab over and that you're on the same line as the return here. And this is where we start to define our code. And what we want is we're creating a random time. We want to set a random time in our timer 1 object. Okay, so what is over here on our timer 1 object, what parameter controls the length or the time that the timer goes? What?
Oh, sorry.
I'm highlighting it here. It's length. How would I specify this length? Well, you probably noticed by now that there's this particular syntax to the way Python points to operators, and that's op, open parenthesis, then, and this is really important, a single apostrophe, I guess, single quote, and then the name of the operator, timer 1, end single quote, close parenthesis, and then if you're pointing to parameters inside that, it's almost always .par. That means .parameter, and then dot, and then the name of the parameter, and the name will be whatever is over here on the left side when you open up this parameter, right? This is its Python name, length. So op timer1.par.length needs to equal some random number. Okay, so we can use Python to create a random number. There are different Python commands. There's probably more than one that create random numbers. There's a really useful built-in Python function suite that's built into Touch Designer called TDU, Touch Designer Utilities. And we're going to use that because then we don't have to worry about something not being installed on somebody's computer. So we say op timer.par.length equals tdu dot random or rand, sorry, tdu.rand, and then you need a seed number. The random thing will spit out a random number based on the seed number that you give it. But if you give it the same seed, it'll spit out the same random number every time. The association between the seed and the number is random. But the number that it's given is not random if you don't give it a random seed. Okay, so if I say give me a random number, the seed is 5. It'll give me like 32 or something. And then I say give me a random number, the seed is 5, gives me another 32, right? That's why random numbers in computers are not actually random. They're called pseudo-random because they're generated from this seed structure. We can create a very randomized process just by feeding it seeds that are always changing or that are always different from another time that we're calling the random function. And the easiest way to do that is use abs time because that's always changing, right? Abs time dot frame so that it gives us multiple different 60 different 60 different seeds every frame, every second. Okay, so that equals, sorry, yeah. Okay, abs time dot frame. Go ahead and click off of that.
Yours is not going to work.
Mine's not going to work.
Length is not spelled correctly.
Thank you. Lege. There we go.
Can I ask you a quick question?
Yes.
Like, if you wanted the random number to be between like 1 and 4, so to say, would it be like TDU rand, and then would you put like the
We're just about to do this.
Okay.
You've anticipated the next move quite efficiently. So if I do this right now and I click on this button, you're either going to get an error if you did it wrong, or the random time. Oh wait, it's not doing it. Why not?
You didn't connect it to a chop.
Because I didn't connect it to a chop, so it never got its input. So I need to, what am I using? Null 3. So here on my chop, null 3. There we go. Now when I click the button, it'll either work or it'll give me an X up in the thing, and that means I have an error in my code somewhere. But you can see that this is giving me a random time. If I click on my timer here, it's giving me a random time somewhere between 0 and 1. And almost all random number generators work that same way. They give you a floating point value somewhere between 0 and 1, and then it's up to you to do math to that to get it to the range that you want. So we want this timer to be some minimum amount of time. We don't want the wheel to just go and stop immediately. We want it to spin for a little bit of time, and then we want it to be in some kind of range. So how long is the maximum time that we want it to wait, and how long is the minimum time we want it to wait? I think it should go somewhere between at least 3 seconds, and then I want the range after that 3 seconds. It could stop immediately, or it could stop up to 5 seconds after that. So between 3 and 8 seconds. The way I could do that is just by saying on this random number, tdu.rand.abstime.frame, multiply that by 5, which will give me a random number between 0 and 5. And then if I want to offset that to 3, then I can say plus 3, right? And when you're doing equations like this, remember back to grade school math where you learned order of operations, because the computer definitely cares about that. In our case, we want it to do multiplication first and then addition. We don't have to worry about any parentheses. But if I wanted it to do instead of multiplying by 5 and then adding 3, I wanted it to multiply by 5 plus 3, or 8, multiply by 8, right? Then I would have to put parentheses between around 5 plus 3 to make sure that it does that first. Remember, parentheses, exponents, inside, outside. What is it? Does anybody remember what the acronym was?
PEMDAS?
PEMDAS? Something like that, yeah.
Parentheses, exponents.
PEMDAS, multiplication, division, addition, subtraction. Yeah, that's the order.
So why is it 5 first?
5 first, so it's taking this random time that goes between 0 and 1 and multiplying that by 5. So then it goes between 0 and 5.
go between 0 and 5, and then like add 3.
And then
to the
add
first.
3 to that so that we get at least 3 seconds, because then it goes between, so if you have a number that goes between 0 to 5 and we add 3, then it goes between 5 and 8, or goes between 3 and 8. Well, what's 0, if it goes between 0 and 5, what's 0 plus 3?
0 plus 3 is 3.
What's, and then, so you're adding 3. If it goes to 5 seconds and you add 3 to that, what's that?
8, okay.
So,
I got you.
get it?
I was confused.
Yeah. So multiply by 5 times 3, plus 3. And so now we get a randomized timer value every time. And so now we have, these will stop at some random point. They're all 3 wheels are still tied together, but we should get a random number of times that they're spinning. Okay, I don't think we're going to get through the whole thing today. So part of your online lesson will be finishing this up, but we'll see how far we get. Okay, so the next thing, any questions on this so far? Okay, so the next thing, we not only want it to be a randomized time, we don't just want it to be a randomized time, we also want it to be a randomized speed slightly. So we don't need it to have a huge range in speed. And if you look at these things, you start adjusting the LFO speed here, frequency. So I'm going to take it off of this and just put it back to constant. You can click on the constant flag to do that. You can go back to your expression just by clicking on the expression flag. So I want to find a range of numbers that I like for like the minimum speed that I want this wheel to spin and the maximum speed. I think 1 works as a good maximum speed. I don't think I want it to go too much faster than that, otherwise they're just going too fast to see what's happening. So I slow it down and I'm like, okay, that's too slow. I don't want them to go that slow because then they might, if they're only going that fast and it's 3 seconds, it might only increment 1 or 2 values. So I thought that between 0.5 and 1 was a good range of speed. So what I'm going to do is I want to create another random value that I'm going to assign then to the speed that I'm going to assign to the frequency. I could just set the frequency here in the code, but we actually want to do some things with easing and stuff. So we want this to actually be in a container, in a chop that will just hold that value until we need it. And the object I usually use for that is called a constant. And a constant, you can either, here in parameters, set it to be something, or you can set it to be something through Python. Yeah. So we're going to actually change this number in Python. But let's give it a good name so that we can easily reference it. And we're going to call it random. What did I call it? Random. Where did it go? Random speed. And I'm using camel caps. Random speed. So now here in our chop execute up here on the same line, on the same definition of on to off, on off to on rather, we want to add a new line before the return and add something to set this set the random speed. So again, we just do op, open parentheses, single quote, random speed, single quote, close parentheses. And now I'm going to say dot par, and then I got to figure out what the actual parameter is called. So I click on random. I'm going to close this viewer for now. I click on random speed, and I'm looking at its on this channel 1. If I expand that, you can see it has name 0 and value 0. So it's .par.value 0. So here on my chop execute dot par dot value 0 equals, let's grab this same TDU random stuff from above, copy and paste it. But in this case, we want it to be somewhere between 0.5 and 1. And so what we can do is, instead of multiplying it by 5, we multiply it by 0.5, and instead of adding 3, we add 0.5. So then it's a random number that starts at 0.5 and goes up to 1. All right, and so now if I click this button, you can see that I get a different random speed in that random speed constant. We haven't done anything with that yet, but we will in a minute. Okay, so now if we want this random, if we want the, if we want the speed of the object to be the LFO, the frequency here is what corresponds to the speed. We need it to be controlled by more than one thing, right? I need it to be controlled both by random speed to set its speed and by this select thing to make it stop, the done channel to make it stop. So you can't, so I'm clicking on LFO1 here and changing the frequency back to my expression. You can't really, at least easily, reference multiple operators in an expression and have those multiple operators affect this parameter. Instead, we want to do our merging and all the coding we have to do outside of that, and then have that go to a single output that then we reference here. And I believe we've used this before. There's a chop called override that allows something to create a value, and then if something else creates a value, then whichever the last thing that sent something into it, that's what the override outputs. So let's add an override. And so now I can send the done channel in there override, and I can set the random speed in the override. And now if I click the button, you can see that it gives me the random speed, and then it gives me a done, a value of 1. Which is close to what we want, but we actually still need to flip that over, I believe. And the other thing we need to do, no, I remember what it is actually. We don't need to flip it over. We need to ease out. So we want to do is when this done comes in, triggers, we want to trigger like an envelope that'll slow the wheel down and stop it. There's probably different ways you can do that. The easiest one that I figured out was trigger. If coming out of this override, I add a trigger chop. Like this. And trigger, what it does is when it gets something into it, it'll trigger an attack profile or a sustain profile, where instead of going straight to that value, it uses a curve data that you've established by these sliders to make the value curve from one value up to a different value, and how long you need it to do that. In fact, we want it to go, we're interested on this sustain and decay, right? So under the sustain tab is where it sets the decay. We actually, on the attack, change everything to 0 on this attack, change attack length to 0, because we want it to go straight into its attack. You can leave the peak level alone, but change the peak length to 0. Then on the sustain, which is also, it's both sustain and decay, we want the decay to be, where's that? Hold on. Oh, here it is. Okay. Yeah, we want the decay length to be 2. Max out the decay length. And we want the sustain level to be 0, because we don't want it to sustain at some like particular value, at least not right now. And then we want the release length to be like 0.3 is fine. Okay, so now go ahead and trigger your trigger the button, and you see that trigger. Oh, I'm sorry. I connected it to override, and I actually want to connect it to the select. That's why everything looked weird to me. Sorry. It should be like that right now. Okay, go ahead and click it. You see the done goes to 0, and then as soon as it goes to 1, instead of it just snapping to 1, it snaps to 1 and then tails out. Now if we feed that into the override, instead, get rid of any of the previous connection from your select. Now you'll have some random speed coming into the override and then that tail out. But you can see that that tail out snaps. It snaps to the random speed, then it tails out, starting at 1 always and tailing out. We want it to actually start at whatever our random speed was and then tail down to 0. We can do that with a simple math chop. So insert operator math. And we go to the range here. And it's going between 0 and 1. It's actually going between 1 and 0, but we don't need to specify that. And instead of, on the out range, the to range, instead of going between 0 and 1, we actually want it to go between 0 and whatever is in random speed, right? Because we want it to, if it's sending a 1, we want that 1 to really be 0.685 or whatever the random came up with. So I can create a reference to this. So I open up this, I go to my to range, I switch to expression mode, I say op for open parentheses single quote random speed and quote close parenthesis channel 1. So I'm just going to put bracket 0 bracket, and there we go. So now it'll range that from between what was being created, which is a value between 0 and 1. We'll rescale that to a value between 0 and 0.685 or whatever you have in your random speed. Now go ahead and click your button, and you can see coming out of the override is the random speed, and then it will count down from the random speed to 0. Okay, and so that's what we're going to use to drive our LFO. Questions?
I probably missed something very simple. When I hit the button, it jumps down to 0, and then when it finishes the countdown, it jumps up and then counts down.
It counts down to 0. Do you have this select chop in here?
Yes.
Okay. Hold on. Let me attach this first, and then I'll come look at yours. Okay, random speed, LFO. I just need to get these arranged a little bit better. There we go. All right, so now all I have to do is, instead of driving this off of the done, off of the select chop here on this frequency, I want to drive it to something coming out of this override. And I think I want to use send to a null chop first. Oh, actually, I'm going to send to another object that will smooth out the data called a lag, which will kind of actually, when it gets started, instead of going straight to rolling, it'll kind of quickly ease up. All right, so referencing this lag 1 now instead of select 1. So here, op select 1, change that to op lag 1, and you don't need the 1 minus anymore. So that is referencing the LFO. Again, you can either type it in the way I just did, or you can make your viewer active and drag it onto the parameter and say relative chop reference, that will do the same thing.
Put it into lag 1, or is it just
Huh? You'll take the output of override and put it into lag 1.
you just connect them?
Yeah, you just connect that.
Okay.
All right, and so now I get a random speed imparted to this wheel, and I get a slowdown and a stop. See that? They're all still being driven by the same wheels, but we can fix that. Yeah, we can fix that. Easy enough. Let me see. What do we want to do? Do we want to? Yes, we want to go ahead and encapsulate it now. So now let's go ahead and encapsulate this so that we can, when I say encapsulate, I mean put it inside of a container of some kind, right? Some sort of capsule. In this case, we'll actually use a container chop. Not chop, a container comp. So grab, let's see, this null, your chop execute, your null, your random speed, the timer, the select, the trigger, the math, the override, the lag, your LFO, the null coming out of that, the math coming out of that. And yeah, you could, if you grab this null too, that's fine as well, or you could leave it out. And cut those, or at least copy them and delete them. Cut. And everything gets mad because you have all these references that are pointing to things that aren't there anymore. Now create a container comp and go inside of that and paste it back. And we want an in and an out for this as well. So create a chop in and patch that into the angry null 3 here so that it's not so angry anymore. If you don't like this black screen, and I like to, you can select this and hit the, maybe you have to hit viewer active. I thought you can, oh, okay, so you have to make it viewer active, right click it and say home. And it's not working right. Oh well, doesn't matter. Oh, I forgot my out. We need an out also. Out. There we go. All right. Now, coming out of the out, attach that back to my null 2 over here, or some null that you then send to the wheel. Okay, and my button, I want to go ahead and patch that in. And let's see, that should now reactivate this. If I go inside, is it going to stop? Yeah, it stopped. And the wheel stopped? Yes, the wheel stopped. Great. All right, we're almost out of time. We have like 5 more minutes. Let's see. So if I wanted to have this attached to different ones to different wheels, let's go ahead and name this container. Call this spinner 1. Spinner 1, and we can copy and paste it. And now I have a spinner 2 and I have a spinner 3. And down here, each of these, or we want to create more null objects. To create another null chop and attach that to the output of spinner 2 and another null chop and attach that to the output of spinner 3. And then here on these, wheel 2 and wheel 1 is still attached, but wheel 2 and 3 are also attached to that same null, and we don't want it to be that way. So here where it says op null 2, I'm going to change that to op null null 1, I guess. That's annoying. All right, let's give these better names. Call this null. Call this wheel post 1. Or, yeah, I guess that's right. Yeah, wheel 1, wheel post 1, because we already have something called 1. Wheel post 2, wheel post 3. And now here I'm going to say, instead of null 2, I'm going to say this is wheel post 1. This will be pointing to wheel post 2. And this will be pointing to wheel post 3. What? I must have typed 2 and I meant to type 3. There we go. All right, now let's go ahead and hit the button. And you should get 3 different random speeds, and it should stop at 3 different places. They're all stopping at the same time right now, or they're not stopping in the particular order the way we said. No, they all are. Oh, they're all stopping at exactly the same time. Does anybody have an idea why? Why we're not getting true randomness between all 3? It has to do with that pseudo-random thing. We're feeding it the same seed in every single thing. So all we have to do to fix that is change the seed slightly. So go back in here on your chop exec. Go into either spinner 2 or spinner 3. We got to change these so that they get different seeds. So here where we're calling random time frame on this, let's say on this one we're going to say time frame plus 2. And we actually want the random speed to be a different random number than the random time. So let's add 3 to this one. That's not going to, now when I'm putting it on the inside of those parentheses, it doesn't affect, you're not adding 3 to the random number. You're adding 3 to the seed that's generating the random number. You're still going to get a random number. It's not going to be a random number plus 3. It's going to be just a different random number than something else, right? And then let's go outside, go into the wheel 3, or sorry, spinner 3, and on its chop exec, instead of adding 2 here, I'm going to add 4. And on this one, I'm going to say plus 5, just so I get random numbers all around. And on my first one, actually, I realized we didn't do that. This second random thing on the first spinner, where I'm saying absolute time frame, I'm going to say plus 1 here. That way, it gets a different seed than what was driving the length. The speed gets a different seed than what was driving the length. Does that make sense? Otherwise, fast speeds will always have short timers, and slow speeds will always have long timers. We don't want that to happen. We don't want that correlation to happen. Now try it again, and we should get 3 different speeds and 3 different stop times. Boom, boom, and boom. All right, cool. So we're basically out of time for right now. Let's see. Do we have, let's put it in. And here's my button. All right, so I wanted to show you this. My button doesn't work. Why? I don't know. I do know a little bit. I think it has to do with, it either has to do with cooking, but I think this actually has to do with being behind where your objects are. There's something in your button, in your settings for your button, called depth layer here under layout. If you set that on basically anything greater than 0, then your button will work. So I think that's a dumb kind of thing of the program too, but I feel like there's something else going on there that I don't understand yet. But I'll try to figure that out and get back to you. Okay, so what is left? What did we not get done today that I wanted to get done? We need to still add. We got a good easing system. We have a good random stop system, But what we don't have is something that stops the wheel when it gets to an integer. So I'm going to add that in the video for next week. Your homework for next week. So you won't turn the homework into me next week. You're going to turn in something after the following week, and it'll be 2 weeks worth of homework. So you can work on this now and not have to do 8 hours of homework between now and 2 weeks from now. What I think you could probably accomplish now this week is to go ahead and figure out how to move this button to be over the handle and how to make it invisible. All you have to do is go in there and turn alphas down to 0, get rid of the text. You can turn on, there's some parameters in there called border. You can turn on those borders temporarily so you can see where the button is to position it where you need it. So you could do that. The other thing, that will probably be in the video anyway. One thing that I don't think I'm going to put in the video, but I would like you guys to do, is figure out how to put some graphics on this object. There's a hard way and an easy way. The hard way is way outside of the scope of this class, and that is to actually UV map the model. If you guys have that kind of experience, go for it. Make it look beautiful. If you don't have that experience, there are several flat areas on this model that we can just stick another object that you texture. So let me just show you real quick. I'm not going to go into it, but let me just show you what kind of objects you would use. You can go in here on SOP and make a rectangle. Is that what it's called? A square? What is it called? Damn it. Rectangle. A rectangle SOP. And I can add a texture to this rectangle SOP the same way. Matte, a Phong, material, right? And then I grab something. And whoops, why didn't that work? Oh, I guess I have to put it in my thing first. Oh, that is a PSD, you're right. Here. So I create a color map, and then I apply the color map to that, and then I put that in my, I place this, let's see. I'd have to then go and make sure to put this inside of a geometry component and put it so that it's here in my scene. But I could move, I could warp it. I could you could either inside your geometry component you could scale it if that didn't warp your image the way you didn't want. If you didn't care about whether it warps the image, you could just scale the entire geometry component till it fits the size you want. Or you can go in here on your rectangle and you can change the size. You can specify the size over here to be something like 2:1. Now it's twice as wide. And then I can make a graphic, or I can pull graphics from the internet and paste that on there, and then arrange this, put this rectangle in the scene such that it lines up with either down here or up here or something on the side of the slot machine. The other thing that we'll ultimately want to do with the slot machine that we've done before with objects is have camera motion, some way of looking at the side of the slot machine, or maybe an animation that starts further away from the slot machine and then flies into it. You guys could do some camera motion either using LFOs or a slider or something like that. So for homework for now, I would say look forward to the video that I'm going to have for next week, but go ahead and start texturing this object with graphics and start to figure out how you want to move the camera. And then you can add a button to this. This button, make it over here on the handle. Okay? And then next week, there will be no class, but there'll be a video, a YouTube video that I'll post on the website. And your assignment will be to patch along with that video and finish up the logic system. So we'll have to, once we get the thing to spit out numbers and consistently spit out the right kind of numbers, then we'll have to start adding the Python code that decides whether you won or not. All right, so that will be in the video next week, along with just the rest of this number wheel stuff. All right, cool.